Right, I think we are streaming. Can someone verify that in the chat? And also if the sound is all right. Things like that. So basically we are going to, everything sounds great, awesome. So basically we are going to continue where we left off the last time with our stock analysis project. Let me find the Python file. All right. So basically we created this project the last time, which fetches intraday stock data from using the Alpha Vantage API. And last time we were able to create a script which fetches data from the last month. Let me get my drawing tool ready. So we were able to get data from last month, and in this stream, let me show you the agenda. So in this stream, we are going to just quickly review what we have at the moment, what we did last time. Then we are going to adjust the code to be able to fetch more data from Alpha Vantage API. The maximum is 2 years, and we will probably choose 6 months for now to basically, because that's the amount of data that is in the limit that we can extract from Alpha Vantage API in a couple of hours. But technically we could do all the 2 years, and then we will explore the data set using data visualization using Plotly in Python. And I gathered some questions that we could answer using very simple data exploration queries. Yeah, so this is the agenda for today. So first, let's review quickly the current code just to get up to speed. Also, since last time after the stream, I uploaded all the code from my computer to GitHub. So if you go to the Timescale GitHub and find an examples repository, and in that examples repository there is a stocks analysis project. You can find all the prerequisites and all the steps that you need to do if you want to basically do the same project. You want to analyze stocks. Here's all the create table scripts and the Python script as well. So you can basically replicate this project. Alrighty, so the very first thing we did the last time is as we created this 𝗥𝗲𝗃𝗃𝗃 function, which is basically a web scraper. It scrapes symbols, ticker symbols from a website. The whole point of this is to just get the symbols, and also if there is a change in the top 100 US companies, or there is I don't know, some other company joins the top 100, it's dynamic. Because we could also have just used like a static CSV, but then if something changes, we would need to update that manually. So this way it's dynamic. And then we use the Alpha Vantage API to request intraday data. This function fetches historical intraday data for one ticker symbol in 1 minute intervals. We use the 𝗥𝗲𝗀𝗃𝗁 to batch insert these records. We use the 𝗥𝗲𝗃𝗁 and copy manager instead of just inserting row by row, because it's much faster this way. And in the main function, we just basically iterate over all the symbols for testing purposes. I think the last time we only did 10. But yeah, we are iterating over the symbols, fetching data for each symbol, and inserting that data into the database. And the end result last time was, let me get my table. So we inserted data to this table where we have stock date time, opening price, closing price, lowest price, highest price, and volume for each symbol. Now let's modify this script to include not just the last month of data, but include much more. So in order to do that, we basically need to modify this part of the code, because currently we are only requesting data for year 1, month 1. And basically, if you don't know, Alpha Vantage API slices up slices up the data, so you cannot get all the data, all the 2 years worth of data in one huge file, because that's a too big file. And instead, you can get the data in 1 month batches. But because of this, we need to create some kind of a loop to iterate over each month and get the data in slices. So maybe the best would be to create a function which basically determines this string, which basically returns the slice, because the first month is year 1, month 1, the second month is year 1, month 2, and so on. So let's create a function called let's call it getSlice, and it should have a parameter which determines which month we want to request, and it will need to be an integer. So if we say month is 1, that's gonna be the last month. If we say month is 2, that's gonna be the second last month. And basically, so this is the string that we have, but we have a different string for year 2. So let's create an if which is so if the month is equal or smaller than 12, that means we need data from year 1. So we need this string. And let's add the number. So if let's say we are requesting the 10th last month, it's gonna return year 1 month 10. Otherwise, return this format and month. All right, so basically, if we go back to our fetch stock data function, the slice value is going to come from this getSlice function. And we will also need to get the month values from somewhere. So let's add it here as well as another parameter. And now basically we just need to create another loop because currently the one loop we have is just for the symbols. But we also want to iterate over months. So let's create another loop. 4 months and basically we just need to iterate over numbers here because the getSlice function needs an integer. So let's use range. And now what we want to put here depends on how much data we want to get. So if we want to get, let's say, the last 6 months of data, then we will need to get basically month 1, 2, 3, 4, 5, and 6. So that means iterating starting from 1 and going until 6. So that means I need to put 7 here. And we also need to put the fetch stock data inside the loop and also the insert function inside the loop. And so this will iterate over 1, 2, 3, 4, 5, 6. And we just need to pass the month number for fetch stock data. So I think this should work. Now, so the reason I chose 6 months, because you can do, like, if you do this project yourself and you are on the free tier of Alpha Vantage's API. Let me just check the docs. So there is a limit regarding how many requests you can make, and I think you can make where is it? Yeah, so you can make 5 API requests per minute and 500 requests per day. Which I think if you do the math, that's gonna be like if you want to extract data for 100 stocks, 1 minute intervals, that's gonna be you're gonna be able to get 6 months of data in 1 day on the free tier. So that's why I chose 6 months. Now it's still gonna take maybe a couple of hours to get it. Not because the ingestion is slow. That's actually, I think, it's like it's between 1 and 2 seconds per batch. But what's gonna slow you down is the oh, I just closed it. It's gonna be the 5 requests per minute. So that's gonna slow you down. But we can start running it just to see if it works. And then I can show you the end result. If you let it run until finish, I can show you the end result, what it looks like. So let's create a new terminal with our environment. So if we run stock analysis, okay, so it's fetching data for Apple, which is the #1 stock currently. Okay, so there is some issue with my connection string. Interesting. Okay, let me check my config file. I hope you cannot see that. Yeah, so I actually don't have the proper config files, so I need to find it real quick. Okay, I got it. I paste it. All right. So let's try it again. Yeah, so this fetching data is just means that fetching data from the API, and now it's inserting data. So the codec connection seems to be working. And we can check the database. So currently we are inserting data to stocks 2. Here. So if we quickly check the most recent records, order by stock date time. Descending. Yeah, so we have data from the 17th of June, which was yesterday, and which is correct. And because we don't, the API doesn't have data from today yet. So this seems to be working. So I will stop it right now, and I will show you the database or the table and what it looks like if you let it run for. I think it took like 2 hours to fill the database. So I have this table called stocks new, and I ran this same script pretty much to get 6 months of data. So this table stocks new has 6 months of data that we can analyze. So let's see. Let's go back to our agenda. So we adjusted the code to fetch more data. Again, I'm just fetching 6 months, but you could do 2 years if you want to. And then now let's explore the data set. So for that, we could use a Jupyter notebook, but I will also create just a new Python script for all the queries and the visualization code and all that. So as far as visualizations, I just wanted to quickly mention what tools you have when you're doing this kind of thing in Python. So first of all, you have matplotlib, which is basically, I think it's the most popular Python visualization tool, and it's really good. Like, it's really powerful. You can do all kinds of things. Now, my only issue with matplotlib is that it's like, even if you're just looking to do something really easy, like, let me find some really easy, like a horizontal bar chart. It takes like you need to do a lot of things to create just a very simple bar chart. Oops, which like, it honestly, it should be just one line of code. By you know, you just need to define the y values, the x values, and if you want to do some you know, if you want to make it nice with colors or whatever. So that's why I don't like matplotlib for very basic stuff that we're doing right now. Instead, I'm going to be using Plotly, which is also open source. Matplotlib is open source as well, but Plotly has a hosted version, but also an open source version. And what I really love about Plotly is that it's just very easy. Like, it's literally one line of code to do very simple stuff. Let me look at basic charts. No, actually, let's look at line charts, because that's what we will want to do with stock time series data. So for example, in order to create a line chart, you literally need just one line of code. Like, you need to get the data into a data frame, which is also really nice, that you don't need to like create like arrays or whatever. You just need to get the data in a data frame, pass that data frame to the Plotly function. You know, define the x, y, maybe a title, and basically that's it. It generates the chart for you. So I really like it. And it's based on JavaScript. Like, I don't know if there is any Python visualization tool which is built in Python. Like, most of the good or the easy visualization libraries are in JavaScript. But yeah, so we're using Plotly. So let's install Plotly. I think it just pip install Plotly. Yes. So pip install Plotly. You can import it. And yeah, so one thing I wanted to say as well is, so Plotly has this package called Plotly Express, which is basically what we're going to use. And it's the cool thing about this is that it's very high level, which can be bad if you want to do like low level things, but in our case it's really good. It's very easy, high level. And also if you want to like go deeper, I cannot find it on the left, but Plotly has a package for lower level stuff. So basically if you want to go if you want to do or create visualizations on the same level as if you were using Matplotlib, you can do it with Plotly as well. Just use not the Plotly Express, but the other package, which is, I'm not sure what that's called. Anyway, we are going to use this package. So let's look at an example code. So this is how you import it. And basically first we need to get the data into data frame. So for that we will also need pandas, but we actually won't need to import that because it just used the internal if inside Plotly, unless we want to do some transformation on the data frame. So let's see. So yeah, we need to actually import pandas because we want to use the read SQL function to get data from TimescaleDB. So let's import pandas as well. And let's read data from the database. Read SQL. We will need a query. So for the query, let's go back to our README. What do we want to do? So the first query we have, or question we have here, is how stock price changed over time. Now here, instead of stock price, we can include any symbols. Maybe we can look at I don't know. We can look at Apple or Alphabet or some of the more popular ones, and how their price changed over time. And we can use a line chart to visualize that. So let's go to dbeaver to figure out what script we need. So basically, let's create a new script, SQL script. So we are going to use stocks new, and we're going to. So we need the prices. We are going to use the close price or price close column, which is basically the closing price for that minute, because we have minute interval data. But we want to visualize this data set or the data frame basically on a line chart. So we will need to think about what values do we want to have, or what values we need to query from the database for the x value. So on the x axis we will need time, but it would be really crowded if we request all the rows, which is basically a new row for every minute. So let's use TimescaleDB's time bucket feature, which is going to basically bucket our rows together. So let's say we want to get data. So we have 6 months of data. So what we could do is maybe use a weekly bucketing. So we have one price point for each week. And that price point should be, well, it could be the starting price or the last price. Let's use the last price for each week. So if we want weekly buckets, we will need to pass 7 days as the first time bucket parameter, and then the name of the time column, which is in our case stock date time, and let's call it time frame. So we have weekly time frames, and we also need basically the last value in each bucket. And for that we can use, let me show you the documentation if you haven't used it yet. So we can use TimescaleDB's TimescaleDB's last feature or function, which is basically like it basically gets you the last value in the column, which in our case is the price close column. So we will need price close. But with the last function. And this function also needs, so it needs the value to return, which is price close, and the timestamp column, which is stock date time. And let's call it last closing price. All right. So if we run, excuse me. So if we run this, let's see what we get. Yeah, we need to group by, obviously. So we group by the time bucket, which is time frame. Now this will take a, yeah, so it was actually pretty quick because considering that we are we don't have a condition, like we're requesting the last closing price for each symbol. Yeah, so basically we got 26 rows, which is right, sort of, because we have 6 months of data. So it looks right. And basically let's choose a symbol. Let's choose, for example, Apple. So if we choose Apple, and let's order by the time frame. Order by the time frame, yeah. Time frame, and also select symbol as well, just so we know it's Apple. All right, so we basically have okay, so we have these weekly buckets, and each bucket. So what we see in each row is basically the start or the beginning of the bucket. So for example, this one is for the week of 21st of December last year. And on that week, Apple closed with this price, 135. And we have this data for each week in the last 6 months. So it looks right to me. Now let's try to visualize it. The ordering is fine. Okay, so all right, so let's copy this query. So we have the query. This will read the data. Also, I think it needs a connection. So we will need to do that as well. But we can just copy paste that from the other function. Or the other script. And we need the config file as well. And psychopg2. Okay. So let's see if the data frame looks right. So we run explore.py. Okay, so it looks right. I only requested the first 3 rows, but we have the symbol column, we have a time frame, and we have last closing price. So based on this, we should be able to generate the chart with Plotly. So Plotly, yeah, so we imported Plotly Express here. Now we can use px.line, and I think it needs data frame as the first parameter, yes. And then we need to define the column for the x axis, which is going to be the timestamp value or time frame in our case. Time frame. The y-axis is last closing price. And I think that's it. We don't need line group because we don't have multiple symbols, just one. Color doesn't matter. Okay, so that should be it. And we also need to yes, it's a figure, I think, and it's basically the same as in Matplotlib and the other libraries. You need to show to actually generate the chart. So if we run this, I think Plotly will open up like a web page. by default, but it can also generate like images or whatever you want. Okay, so we have this huge chart. So we have last closing price on the X or Y, and we have the time frame on the X. And if we hover the chart, we can see the specific value. So for example, February 22, 2021. So it's the, as I said, we are using time bucket, so that February 22 is the start of the week. But the last closing price on that week was 121 based on our data set that we got from Alpha Vantage. And this so this chart, on this chart we have weekly data points. Let's see what happens if we try to get daily data points. So we just go back to DB well, we don't even need to go here, because it's basically, we just need to change the time bucket, the value for time bucket. So right now we are creating 7 days weekly buckets, but if we want daily, we can do 1 day, and that will create daily buckets, and so we will have much more data points. So let's close this one. So this is the new chart, which Plotly just generated. We have much more data points. We have daily data points right now. We can also zoom in if we want to. But yeah, this is basically the chart of Apple in the last 6 months. So we can also try another one. So let's try Alphabet or Google. I need to change it here. Okay, so we don't have data, so I suppose yeah, so that's not the symbol of Google. I think I messed that up. The symbol for Google is just GOG. So we can see that if we compare, let's open the Apple one as well, just so we can compare a little bit. So let's do Apple. So this one is for Apple, this is for Alphabet. Well, we can see that basically Apple hasn't really increased in price in the last 6 months, but Google has increased quite a bit. From December, it was 1,758, and recently it's 2,520. All right, we will in a later query we will also calculate the percentage values, how much is the increase in terms of percentage. So that was the first task, right? So how a stock price changed over time. So we did that. We can also do the same thing with trading volumes. And oh, I also wanted to show that, yeah, so we created this new Python script, which is fine. But for exploration, I just like to use Jupyter notebooks. So let's create a new Jupyter notebook. Let's just call it. Can we call it the same name? Explore. Yes. So this will create a new notebook. Let's import all the stuff we need. So this will import the packages. This will create the connection. And if we run this will produce the same chart. Instead, it won't open a new page. It will just put it here in the notebook. So it's much quicker. So let's do the same kind of line chart for trading volume. So for trading volume, we basically need the same script, except that we are bucketing the well, the time bucket can be 7 days, for example, but we are not querying the last price. Instead, we need the trading volume. But with trading volume, we don't really like, we basically need a sum of the volume, because we have, if you look at the database, and we just delete this. So in the database we have oops. So we have a new row for each new minute, and we also have trading volume for inside each minute, obviously, but we cannot use the last function here because we don't just need the last trading volume. We basically need a sum of all the trading volumes in that time bucket. So what we're going to do is use this same query. The time bucket can be 7 days, but we, instead of using last, the TimescaleDB function, we're just going to use sum. And we will sum the trading volume column. And you can call it just volume. Right. Group by time frame, symbol, order bar. Okay. And on the figure, the y-axis is going to be volume. Okay, so it doesn't work. Let's check the data frame first. Oh, okay, so there is something wrong with our query. Okay. Oh yeah, I said trading column. All right, it's trading volume. So if you run this, this returns the trading volume for each week for Apple. The ordering looks good. So if you go back to the notebook, run it again. So this is the trading volume for Apple in the last 6 months on each week. So this last value is probably no, it's probably good. I'm just wondering, like this week starts June 14. So it's a short week. But in the past Apple had weeks with much bigger trading volumes as well. All right, so this was how trading volume changed over time. So we did that. Let's try it with some other symbol. What symbol should we try? What's the issue here? All right, let's just do this thing. Okay, so we have 101 symbols, which is interesting. We should only have 100. Anyway, let's choose another symbol. And also one thing I wanted to show, I actually forgot to mention that. So I downloaded this data set. It's not dynamic. I just grabbed the CSV from, I think, from GitHub, but it basically has the symbols and the company name. And I wanted to show this because it might be useful for people, because basically this is not so this is not a hyper table. It's just a regular table. And the cool thing is that in the table we're using right now is a hyper table, but just looking at the symbols, you might not know the name of the company. So we can just use hyper table as a regular SQL table. So we can Postgres table. So we can join it with this other table, which has actually the name as well. So if we want to do that, so if we go here we just have the symbols. Again, I have no idea what this symbol is for. So we can just join. And this is interesting because normally with other time series databases, you can actually do this, or it's not this simple to just join a regular Postgres table with your time series data table. But with TimescaleDB, we can do this pretty easily. So if we do inner join ticker t on symbol. Let's just call it sn. So let's see. Let's select symbol and also name. So with this, we basically joined a regular Postgres table with our time series table, which is pretty cool. So let's select Zoom, for example. So ZM. So if we go back to yeah, so here so this is the trading volume line chart. So if we just put ZM here and run it, this is the trading volume for Zoom. Let's see. Let's see IBM. A little different. All right, so we did the second question. Now let's do the third one, which is which symbols had the most transaction volumes or trading volumes in the past, and create bar chart to create a bar chart to visualize this. So basically we can modify this current query we have. Let's go back to dbeaver. So basically we are looking for which ticker symbol had the most transaction volume, right? In the past, yeah, we can try in the last week or last month. Let's try last week. So basically we will need the symbol. We will need the trading volume with sum. I'm wondering if we need time bucket. We probably don't need time bucket for this. We just need a way to select. We just need a way to filter out data. So to only look at data from the past week or 2 weeks or month or whatever. So let's do, so this is fine. In the where we can do, so let's do now, which is basically the current time. And to get the last 14 days, for example, we can do something like this. Let's say 14 day. And the column that we need is the time column, which is stock date time. And we also just need the date. We don't care about the time for now. And let's put this in parentheses. Okay, so now minus the stock date time. And this needs to be smaller than 14 days, which means in the last 14 days, right? We don't have time frame. Yeah, let's do this. Okay, so now we got the trading volumes for each symbol. And what was the question? So, which symbols had the most or the highest transaction volumes in the last 2 weeks, for example? So basically, we just need to order it, order by stock date time, yes, and if you must appear. Okay. So yeah, we need the most transaction volume. So we need to order by the volume, which is volume. Right? This should, yeah. So descending. Okay, so this returned the symbols with the highest trading volumes in the last 2 weeks, I believe. And let's just, yeah, so we are trying to create a bar chart from this, right? Yeah, so we are creating a bar chart from this. So let's just limit it to 5. Okay, so now we got the top 5. And this should work. So we go back to our notebook. Should we... yeah, I should probably create a new entry. So yeah, I don't want to overwrite this. So here I changed the query. Okay. All right. So we don't need a line chart. We need a bar chart, which I'm guessing just bar, right? Bar charts. Yeah, it's just bar. We need the data. We need the X and Y. So the X is, what's the X? Symbol, right? Yes. So symbol. Y is the trading volume, which is just volume. Yeah, that's fine. So if I run this, we should get a bar chart. Okay. So we got a bar chart with the top 5 symbols regarding trading volumes in the past 2 weeks, right? Because we have 2 weeks here, or 14 days. All right. Basically, 𝗥𝗲𝗀𝗲𝗃. I'm not sure what this is. Oh, and we can zoom in as well. T and AMD. Let's okay, let's do that join again that we did last time, just to see the symbols, not just the or see the company names, not just the symbols. So we do inner join ticker t.symbol stocks new symbol. So if you run this, ambiguous, yes. We also need the name. Okay. All right, so let's use this for our bar chart. And instead of symbol, let's use name. Or yeah, just name. Okay, so now we know it's Apple, General Electric, Bank of America, AT&T, and AMD with the highest trading volumes in the last 14 days. Let's try not 14 days, but let's say 30 days. Does it change? No. Still same companies. Let's say 6 months. Can I do month? Probably. Yeah. Yeah, I mean, it's basically the same companies. Interesting. Or no, I think the query is good. I think the query is good. All right, so I think we can say that we did this as well. We might come back to this later because it's interesting that it's the same companies with the highest volumes for each time period. But the query should be good. Like I'm looking for dbeaver, so if I don't do limit, we have a bunch of records. Berkshire Hathaway is with the lowest volume. Interesting. All right. So I think that's done. We have prices of FANG over time. So that's gonna mean 1, 2, 3, 4, 5 symbols and just a simple line chart. So if we go okay, so if we go back to dbeaver, I mean it's pretty similar. It's a pretty similar query to what we did before with the time bucket. When we use the time bucket function. Yeah, I mean it's basically the same query except the where clause is going to be a little bit different. So I always click the wrong window. So if we go to dbeaver and we change it to or well, we could do just a list, something like this. So we have Apple, we have we have Facebook, which is just FB. We have Google Alphabet. We have Amazon, which is this. And we have what's the last one? Oh, Netflix, right? And Netflix is, do we have Netflix? We do, so that's NFLX. Okay, so where symbol in this list, which are the FANG symbols. Do we need to change anything? So last closing price. That should be fine. Now the only basically we do the same query, but with this one we only had one symbol. Now we have 5. We will probably need to change something, but let's just run it. So I will just copy paste this into a new entry, and I will use the new so I will use the new query. Okay. We have time frame and last closing price. Let's see what it does. I think we need to modify how the so okay, so we definitely need to modify something. Yeah, I mean the issue is that we just have a bunch of data points. So the line chart is going crazy. So yeah, we have 1 day. Yeah, so basically that's a bunch of data points from the last 6 months. So let's just do 30 days. So if we do 30 days, okay, so yeah, so the thing is, yeah, so as I said previously, we only had just one symbol, so this is what happens if you have one symbol. But for multiple symbols, I think you need to add a color parameter to separate the like currently we just have one color for each symbol, which is not good. So the color is going to be based on symbol. So if we run now, yeah, much better. Okay, so basically we have yeah, we could join it, but we know these companies. So we have Apple, Amazon, Facebook, Go, Alphabet, and Netflix. And basically we can see the prices over time. This is from the last 6 months. And the data points are monthly. So basically we have January, February, March, April. We have one data point for each month. What if we do... I mean, we can already see some things with this view. So this is Amazon, and the red one is Amazon. The purple one is Alphabet. There is a little bit of correlation there. When we have monthly data points. It's harder to see for these ones. Well, there is some correlation that we can see even on this scale between Netflix and Facebook. All right, interesting. So let's try one chart with more data points to see if that's gonna do anything or if that helps. So instead of 30 days, let's do... So what if we do 1 day? We're gonna have a bunch of data points, so it's probably not gonna be good, but I'll just try it. No, it actually looks fine. So we have daily data points. Now it's harder to see the correlation, but we can still see it, sort of. And let's do... So because we have minute interval data, we could do something like an hour. But I'm not sure what that will look like. That's more data, so it takes a little longer. So this is hourly data. Let's zoom in on these two. I mean, you can still see the correlation. What if we do... well, if we just do 1 minute, we don't need the time bucket function, but let's do 10 minutes. And it's a bunch of data, so it's taking a little bit. But here it is. Let's zoom in on these. Okay. I mean, one thing you can see is that, for example, Apple is it's almost like a straight line. And if you compare that to Netflix, Netflix has, you know, ups and downs. It's much more volatile. Although the scale is not perfect because obviously Netflix has a higher price. So even if the value itself is like the change itself is bigger when you look at the number, in terms of percentages, it might not be that big of a change. So, and with that said, let's actually do a query with percentage values, because I think for stocks, especially when you want to compare stocks, I think percentage values are much better, or at least to, you know, see change, or see the change. So I think that's gonna be the last question we have. So which symbols had the most daily, weekly, monthly gains and losses? So for this, we need to calculate percentage. So basically, if we go to dbeaver, we will need, I'm just going to delete this because we need a totally different query. So we will need a symbol. And what else? So one thing for sure is that we will need to subtract prices. To see the difference. So basically, I will probably need a subquery for this. I mean, I don't, but it just might be cleaner. So let's just create first the subquery, which will create the time buckets. So we will need a time bucket. And what interval? Well, what's the question? So yeah, daily, weekly, monthly. Let's do the daily one first. So we just do 1 day. Stock date time as time frame. So if we do this, we will, yeah, so basically we want to compare the first value or the first price of that day with the last value of that day. So we're just gonna use the same function that we used before, which is last, so that the last function will get us the last value in that time frame. And then we're gonna use also the first function, which will get us the first value in the time frame or time bucket. So let's do that. So we got the time bucket. Then we can do, so let's do the first one. So we could, so basically we have, because we have candle data, we have price open, and also we have price open, price high as well. Let's just use price open. and stock date time. So this will give us the opening price, the first opening price value. Then do the same thing with last. And here we want to get the last price close value, I think. So if we do this, I mean, basically we could use opening price or closing price for both. I don't think it matters that much because we have 1 minute interval data points, so it's not a big of a difference. So let me just break it up a little bit. So we have opening price, we have closing price. What does it do? Yeah, so we'll need to group by as well. Group by symbol. Time frame. So it's taking a little bit because, yeah, so we have I think, actually, did we check how many records we have? Let's quickly check. Because I think we have like 25 million records or something like that. No, only 5 million. Interesting. I remembered much more. Anyway, so we have this script. This returns the first opening price and the last closing price for each time frame, for each symbol. All right, and now basically we need to subtract the closing price or the opening price. So we need to do opening price or closing price minus opening price. Yeah, and that's why I wanted to do a subquery, because I don't think you can we can try. So we can do, so let's see, so we can go here, closing price minus opening price. And this will give us the difference, basically, which is the price change. So if we try to run this, I don't think. Yeah, so that's why I wanted to do a subquery, or I could just copy this whole thing and do the subtraction with this, but let's do a subquery. So if we do this, so this is our subquery, and we can just do the subtraction here, closing, because here it will see closing price and opening price. No. Oh, syntax error. Okay. What's the issue here? So I have a subquery here. And I have a syntax error. Why do I have syntax error? Oh, I have a syntax error in the subquery. All right. So yeah, this was the issue. Yeah. All right. So yeah. So basically, I can. So I need to subtract from the closing price, opening price. That's basically the change, or yeah, the price change. Yeah, so we have the price change now. But these are, yeah, so we need percentages. So what we can do is divide by the closing price, right? But we need parentheses. So we need this, and we can also times 100, and this will give us the percentage values. Yes. So the opening price was for this one, for example, 126. Closing price 130. On December 21st, 2020. And that's a 2.7% change. That looks right. Do we have anything else? What was the question? Which symbols had the most daily, weekly, monthly gains and losses? So we just need to order it. Order by price change. And we need descending. If we are looking for the gain, yeah, if you're looking for the gains, we need descending. If you're looking for losses, we need ascending. So let's do gains first. Okay, so it looks like let's join the ticker table as well again. Just so we see actual company names, not just symbols. Symbol equals I think the sub symbols in the subquery. Okay. And let's limit it because we don't need this many results. Okay. Oh, because didn't I call it sub previously? Or just, I think it's sub anyway. Okay, so we got the top 10 price changes in the last 6 months in a day. And it looks like Zoom had the biggest one-day price change. It's actually pretty recent, 7th of June. Now the thing is, it's so it changed 19 it went up basically 19% in price, but because we are bucketing, so we're using the time bucket function, right? Which means this time frame starts at midnight. It starts at midnight and ends at midnight. So basically, we are looking at these time frames and analyzing these time frames. So it's not necessarily the same time frame as you know, when the market is open. So it's just good to be aware of that. So basically, we have oh, and I didn't do I did the join, but oh yeah, we just have the column here. Yeah. So basically, Zoom had the biggest intraday price change than Tesla, Snap. We have another Zoom on the first day of March. Another Snapchat here. So there are the applications here, which doesn't mean the query is wrong. The query is right. It's just looking at the biggest price changes on any given day in the last 6 months. Now, if we do we need to yeah, we don't have any visualization task here, so I will not I mean, we could visualize this, but let's try not one day, but let's try the biggest losses. So if we do ascending, that's gonna give us the biggest losses, hopefully. Yeah, and Zoom and Snap again in the list. So it looks like Zoom have been pretty volatile in the last 6 months when it comes to intraday changes, which is interesting. We also have Uber, we have this company, Square twice. Interesting. All right, now let's go back to descending, and let's say not intraday changes, but let's look at weekly changes. So I think I can do week to see the biggest changes in a week, in any given week in the last 6 months. Okay, so Zoom again. So it looks like so it was pretty recently in June. There was a week, a period of week where Zoom had an increase in price, 24% increase in price. then Tesla with 18%, and Boeing with 17% in March, which is interesting. I'm guessing in March there were some news about how things will go back to normal regarding flying and things like that. So that's why it increased. That's just my guess. It might be some totally other reason. We have Snap, which is Snapchat, Tesla, Airbnb. Interesting. Let's do ascending. It's gonna be probably the same few stocks that we already seen. It's probably gonna be Zoom. No, actually no. Zoom is not even on the list. So we have this company, 18% price drop in a week in January. We have this other, we have Square, 18%, 17, 16%. Let's do 1 month. Can I do 1 month? With time bucket, probably no. Let's do 30 days. So if we do 30 days, I'm expecting bigger price changes because that's a bigger time period. So we have Airbnb in April dropped 24%, Zoom 24%, Uber 24%. Let's do descending again. We have Airbnb with 20, almost 30% price increase in a month or in 30 days. Paying 21%, Zoom almost 21%. Interesting. So I think that was the last question we needed to answer. Yes. All right. So I think that's gonna conclude this stream. So basically what we did, we adjusted our script. Let me look at the script. So we adjusted the script we have, which fetches intraday stock data from Alpha Vantage. We adjusted this script. Oh, and this, oh, that's why, okay. So we actually forget to, well, in the script, I forgot to remove this part because this will limit the number of symbols in the database to 10. So I will need to remove this, but before, so this script will be available on GitHub. I will go through the code once more just to make sure that everything is right. And if you want to do it, if you want to do the same project, you want to do everything that I've done in this Jupyter notebook, want to do all the visualizations, all the code will be on the GitHub page. And if you watch it, if you watch the recording of this stream, you can probably find all the links in the description of this video. So you can go to GitHub, you can go here, you can run these scripts, you can create your own database, you can even use Forge if you want to, or if you just want to set up your own PostgreSDB with TimescaleDB, that's fine as well. Then you need to install the requirements, create a table, and you can just run this script and try all the interesting visualization stuff yourself. All right, I think that was it. Thank you, and we will continue this this script. We will continue working on the script in the next stream. See you in